Hi, welcome to my tutorial video. Now in this video, we will be looking at tutorial, know how to solve these things. So firstly, let's have a look at number one, the composite curves. Number two, we'll be looking at the cascade method. And number three, which is finally, we will be designing the heat exchanger network. Now the purpose of us sketching the composite curves is to enable us to calculate the pinch for hot temperature and pinch for cold temperature. And also the composite curves, we're going to make use of it to determine our utilities. Recall that we have the cold utility and we also have the hot utility. So that's the purpose of us sketching the composite curves. Same applies. Performing the cascade method based on the same information, we're supposed to get similar answers when we do the cascade method and the composite curves. But we know that for curves, it's gonna be a little bit challenging because we won't be 100% accurate when we do these composite curves, more especially if we are using our freehand drawing. And then later on, and then the cascade method, we can also use it to determine the pinch point temperature, the pinch for hot, and the pinch for cold water as well. And then again, we can also use it to determine the utilities. Now, without wasting time, for this session, we will be looking at the composite curves where delta T minimum is 10 degrees Celsius, right? And the question is, how am I going to sketch these composite curves? Am I quickly going to run to my Cartesian plane, my graph, my grid graph? Am I going to plot all of those temperatures that I see over there and voila, my composite curve is done? No, that's not how we're gonna do it. Now, how we draw a composite curve, you have to recall that we have two curves that we are actually going to draw. We are going to draw a curve for hot water, and then we are going to draw, okay, so I can say a hot stream, and we are going to draw a curve for a cold stream. But there is a way on how we can draw these curves, right? So now here's a compiled table without wasting time. Here's a compiled table that we're going to start with. So in this case, we will be plotting the temperature versus delta H cumulative. That's what we are going to do. So meaning on the y-axis, we are going to plot our temperature, and on the x-axis, we are going to draw our delta H. But in this case, our delta H, it will be cumulative, okay? The reason why we have delta H cumulative is because we are not going to draw them separately. You can draw each stream separately on one graph for hot. You can also draw each stream separately on one graph for cold. And then now you can combine those streams together to make one curve. For cold, you can do the same thing, combine those streams together to make a net for cold streams. Okay, so rather, because we don't want to waste time, we just want to combine all of these streams together at once. Okay, so firstly, we're going to start with the hot streams, and then the question is, then how are we going to start with the hot streams? Now, to start with the hot streams, we're going to make use of this table over here. So now for hot streams, I will change my color over here. I will take red. So for hot stream, if we go back to our table, um, the supply temperature was 250 degrees Celsius, and the target for H1, and the target it is 40 degrees Celsius. So meaning what we're gonna do over here is, let me erase here to create space for myself over there. So meaning for H1, we're gonna move from, for H1, we're gonna move from 250, which is the supply, to the target, which is 40 degrees Celsius, right? That is for H1. And then for H2, which is stream number 2 uh, for the hot stream, is from 200 to 80 degrees Celsius, meaning our supply it is 200, and then our target it is 80 degrees Celsius, meaning it is from here. This will be our H2, which is from, okay, let me fix that. Let me fix that as well. So here we have our H2, which is from 200 to 80 degrees Celsius. That's our target, right? So these are hot streams that are provided. So what we're going to do is we're going to look at the temperature difference between the intervals, meaning we have 250 to 200. The interval there, it will be 50 degrees Celsius. And then from 200 to 80 degrees Celsius, the difference over there, I think it's gonna be 100 and what? Let me see, 200. This is easy, but yeah, it's 120 degrees Celsius. And then from 80 to 40, that will be 40 degrees Celsius. And then that's it. And then now let's come on this side over here where we have sum of CPs. So in this case, we will be adding the CPs of our streams. Firstly, what I want you to recall is that from the initial table, we were given the heat capacities for each and every stream. For H1, it was given to be 0.15. We can see that it is. And then for H2, it is given to be 0.25. So for H1, it is 0.15. Over here, we have 0.15, and then over here, we have 0.25, right? Awesome. Let me go confirm 0.15, 0.25, yes. Now, in this column, what we're going to do is we're going to add the CP values within the interval of 50, between 250 and 200. So we can see that we have only one stream that flows within that interval, which is this portion over here, right? We have only this portion, and that portion, it has a CP of 0.15. So in this case, we have 0.15. For H2, it's 0. We do not have stream over there. So we're going to say 0.15 plus 0. That will give us 0.15. And then we move to the second interval, which is between 280, which is within 120 interval. Now, what we're going to do over there is we are looking at the streams that are within that interval. We have H1. We also have H2. So meaning we're going to say 0.15 plus 0.25. So when we say 0.15 plus 0.25 in that stream or in that interval, we're going to get 0.4. We do the same thing for interval 80 and 40. We have 40 there. We only have one stream, which is the stream over here, which is 0.15 plus 0 because H2, we don't have nothing over there. So we're going to have 0.15 plus 0. That will give us 0.15. And then the question is now, how are we going to calculate delta H? By making use of the quiet thermodynamics equation, we know that delta H can be given by specific heat capacity multiplied by change in temperature, right? So in that case, what we're going to do is to get this delta H, we're going to make use of that equation, Cp multiplied by temperature. So basically, we are going to multiply with these two columns, meaning we're going to say 50 multiplied by 0.15, right? So 0.15 multiplied by 50, and then here we're going to get 7.5. And then we do the same thing at the bottom, 120 multiplied by 0.4, we get 48. We do the same thing, we're gonna say 40 multiplied by 0.1, we get 6. Now for cumulative, we're gonna start it at the bottom, right? We're gonna start it at the bottom, moving upwards, meaning we are moving in this direction. I will be saying this 0 all the times here. We're gonna start at 0 for hot streams, okay? So meaning on 0 on our Cartesian plane, whereby our delta H it is 0. So meaning we're gonna start at 0. So what we're gonna do is I will be saying 0 plus 6. It will give me 6, right? That's cumulative. And then I'm gonna say 6 plus 48, meaning I'm gonna say these guys together. I'm gonna add them diagonally, 6 plus 48. That will give me 54. That will give me 54. Again, diagonally, I'm gonna say 54. I'm going to say 54 plus 7 comma 5, and then let's see how much do we get. We get 61.5, right? So this is the cumulative frequency. We get 61.5. So that's how we fill up this table for hot streams. So when we go to the graph, what we're going to do is we're going to plot this against this. Okay, we're going to plot that against that. So let's see how are we going to plot that. So now, so by the way, again, you still have to understand that, okay, no, we're gonna plot, we're gonna plot, let's do this so that I can show you what we're gonna plot over there. Actually thinking of completing this table first, and then we'll go to plot, okay? So let's do for the cold streams. So firstly, before we do the cold streams, let's go back to our provided table first. For cold streams, which is C1 and C2, our temperature target for C1, it's sorry, our supply temperature for C1, it's 20, and then the target is 180. We are hitting the stream over there. That's C1, 20 to 80. So we are moving from, for C1, 20 to 180, right? 20 to 180. And then for C2, let's see, we are moving from 140 to 230. So we are moving from 140, that will be C2, 140 to 230. Then this is for cold stream. And then the CP values for both C1 and C2. For C1, we have 0.2. For C2, we have this and this. For C2, we have 0.3. So here we have 0. Okay, here's my pen. 0.2, and then here we have 0.3. And then now let's work out the temperature difference, just like how we did on the other side of the equation. We're gonna say 230 minus 180. Definitely we're gonna get 50 degrees Celsius. And in 180 and 140, that will give us 40 degrees Celsius. I don't need to write the units there. 40. And then 140 and 20, that will give us 120. So one will give us 120 degrees, and that's it. And in the addition of enthalpies, we can see that for this interval between 230 and 180, we have only one stream for C2, which is 0.3. So for cold, it's 0. So we're going to say 0 plus 0.3. That will give us 0.3. And then for the second interval, which is between 180 degrees to 140 degrees, we have two streams over there, which is 0.2 and 0.3. That will give us 0.5 when we add them. And then on the last stream, which is between 140 and 20, we have only one stream over there, which is C1. Its CP is 0.2, right? And then from now, then what you're going to do is we're going to determine delta H. We're going to determine delta H. So how are we going to determine delta H? We're going to multiply both sides. So we're going to say 50 multiplied by 0.3, like I told you, the equation that we make use of. So we're going to say 50 multiplied by 0.3, that will give us 15. And then 0.5 multiplied by 20, that by 40, that will give us 20, it's half. And then 0.2 multiplied by 120, that will give us 24. Okay, so to determine the delta H cumulative at this point in time, we're not gonna do it. That's why we have X over there, because the only stream that we're gonna start with on our graph sheet, we're gonna start with the hot stream, and the cold stream, it is the one that we're gonna move horizontally so that we get to T delta T minimum of 10 degrees Celsius. I will explain that when we get there. So that's the reason why we do not fix this cold stream floating on the graph. So we're gonna fix, meaning we're gonna draw this hot stream on the graph so that, yeah. But let's go, let's see, so that you can understand what do I mean by saying that. Let me do this. Recall that we are doing number one. We are doing number one, sketching the composite curves. So this is the first approach on how we're gonna do it. And oh, by the way, I was actually talking about the plot. So the question is, how are we going to plot this? This is simple. This is how we're going to plot this, okay? To plot this, let me do this. To plot this, we're gonna plot cumulative against the temperature, like I said before, okay? So let me go to the plot. Okay. A lot of challenges here. That's all. Okay. Oh, by the way, I want to confirm the scale for delta H, because the maximum is 61.5. That side it's okay. This is what I want to do, okay? I'm going to fix my scale over here. This is too huge. So we can use fives. Let's see if fives will fit in. So here we have 0, 1, 2, 3, 4, 5, 10, 20. Yeah, that will do. So this will be 10, this will be 20, this will be 30, this will be 40, and this will be 50, this will be 60, this will be 70, and this will be 80. Let me say 90. Just want to do 100, right? So this will be our scale. So meaning on the x-axis, we have delta H, right? Whereby each line represent 1, from 0, 1, 2, 3, and so forth. So, and then on the y-axis, we have the temperature in degrees Celsius. I don't have enough space over there. I will just say, just write it here, the temperature in degrees Celsius, okay? That's what we have on our y-axis. So the question is, how are we going to plot this hot stream? It's simple to plot. To plot this hot stream, which points are you going to consider? Here we have, for the temperature, here we have 0 degrees. So from 0 degrees to 40 degrees Celsius, we have 0, right? From 0 degrees to 40 degrees Celsius, we have 0. So meaning from 0 degrees to 40. So one line here represent 5, meaning this is 0, this is 0, this is 5, 10, 15, 20, 25, right? So meaning in this case, let me magnify that so that you can be able to see. Do this. So, and then, yeah. So one line, they represent 5, okay? It represents 5. So this is 0, 5, 10, 15, 20, 25. 30, 35, 40, 45, and 50. So one line is 5, right? So what are we looking for? We are looking for 40 degrees Celsius, from 0 to 40 degrees Celsius. This is 50 degrees Celsius. So this is 25, 5, 25, 30, 35, 40. This is where we have 40 degrees Celsius. This would be our 40 degrees Celsius, right? From 0 to 40 degrees Celsius, our cumulative delta H, it's 0. It's the first point. And then the second point, from 40 to 80, we have 6, right? From 40 to 80, we have 6, meaning from that point to 80, where is 80? So to get 80, I can say, because I want to know how many number of lines, I can say 80 divided by 5, meaning it's 16 lines. So I know here at 50, it's 10 lines, 11, 12, 13, 14, 15, 16 lines. So 16 lines, that's where I know I have my 80 degrees Celsius. 80 degrees Celsius, right? So this will be my 80 degrees Celsius. So 80 degrees Celsius from 40 to 80. From 40 to 80, we are going to plot 6. So on the x-axis, we are looking for 6. So one line represents 1. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So one line represents 1 on the x-axis. So that means over here, we have 6 over here. So that means from 40 to 80, we have 5, 6. 6. Well, 6 will be there. Then we do continue from 80 to 200. From 80 to 200, where is our 200? Where is our 200? There is our 200. How much do we have? We have 54. We have 54. From 80 to 200, we have 54. 54. Where is 54? This is 50, 51, 52, 54 will be here. Oh, it's my pen. 54 will be here. This is 54. So it's from where? To 200. Okay, 54. It's going to be here to 200. It's going to be this line over there. Right? And then the last point, from 200 to 250. From 200 to 250, we have 61.5. From 200 to 250, we have 61.5. Where's my 61.5? Let me come this side. 61. This will be my 61. This will be my 61. This will be my 62. 64.5 will be in the middle. It will be here, right? Awesome. So let's go. It's 60. This is 60. Let me just mark it here so that I don't get confused. I remember this line is 60. Sure, fine. I'll erase it to 250. Okay, that line there, I said 60. It's 60, and then let me, so to 250, 60, if this is 60, 61, 62, 61, 62 is going to be here. It's going to be at that point. Now I can erase this because I'm not going to be able to see down there. Let me see, confirm. Yep, that's it. And then now we are done with the hot stream. We can join the points, right? We can join these two points, join this to that, do this. Oh my God. It's clear. that. It's far away from it. Join that to that. As much as this graphical method, it is not accurate, at least you have to try to be a little bit accurate as much as you can, right? Right, and then we join which point? That point to that point. I knew I'm gonna struggle for this one, but let's try it. It's too heavy. Well, oh my God, that was straight, but it doesn't go where it's supposed to go. Right, we tried. And then we move here. Then we move here. From there to there. And do not forget that the cold stream, the hot stream, it is moving downwards, right? We are cooling here. We are cooling the stream from a target of 250 to that temperature at the end over there. So we can also do it like this. Show that with an indication of an arrow that this is our hot stream. And now this is how our hot stream will actually look like on the sketch. And then now let's go plot the cold stream. Now the cold stream is gonna be a little bit different, and we have to know how to move it horizontally so that we get delta H, delta T minimum, sorry, of 10 degrees Celsius. Okay, so that's why here we didn't, like I said, that's why here we didn't draw the cumulative frequency, because the cumulative frequency, we're going to have to start at 0, and that's going to be a little bit of a problem for us. And then the question is, then how are we going to do so? So if we want to start it from here, we have to start it somewhere, okay? And by the way, the starting temperature, it will be, let's go. The starting temperature, it will be, what am I doing now? The starting temperature, it will be 20 degrees Celsius, right? It will be 20 degrees Celsius. So our 20, let's change the color for blue. So 20 degrees Celsius, let me magnify, 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 and magnify. So let's go back to there. So our starting line temperature, it will be 20 degrees Celsius. Recall line here is 5. 0, 5, 10, 15, 20, 25. It's how much? Starting, it's 20 degrees Celsius, right? Okay. 20 degrees Celsius is gonna be here. This is where we have our 20 degrees Celsius. So the starting line is going to be 20 degrees Celsius. So we're not going to start here at 0. It's either we start here, or we start here, or we start here, or we can even start here. But what matters is where you're going to start, make sure that you have a delta T minimum of 10 degrees Celsius between your graphs. So that's where we have a pinch point, okay? So at this point in time, say maybe if we decide to start, if we start at 20, our delta H is 24. We're supposed to have 24. Let me do this. 24. So we're gonna start here at 20, and then our delta H is gonna be 24, right? So we cannot say, meaning let's try to move to 24. Where is 24? This is 24. Instead of saying from here to there it's 24, we can, yeah, let's try to do it like that. 20 to 24. Why is it 24? 24, show yourself. This is 25. 24 will be here. 24 will be here, right? And then now let's join another point. Another temperature is at 140, and we have 20, right? 140, where are you? I'm gonna say 140 divided by 5. How many lines? 28 lines. So 5, 10, 15, 20, yeah, 5, 10, 15, 20, 25, 26, 27, 28. It's going to be here. This is where we have 140. 140. So 140 from 24. Remember, here we have 24. We have 24. So I'm going to say 24 plus how much? Let's see. I want to move how many units from 24? 20 units. So when I say 24 plus 20 units, it's going to take me to 44. So that means I'm going to have to be at 44, 40, 41, 42, 43, 44. This is where I have 44. So 44 to 140, 44 to 140. Let's go up. Where is my 140? Where is my 140? Show yourself 140. It's there below 150. How many lines? One, two, 24. It's here, right? That's it. Yep. Yeah, that's it. Right. And then now let's try to talk about the temperature difference between, you see, here's the thing. Even if when you join these 2 points, right? You do this to show these 2 points. I'll show you something. And then it's fine. You're using your pencil, right? And then you're gonna erase after that. And then let's do 180 with 15, 180 with 15, 180 with 15. So meaning from 44, I'm gonna add 15. And then that will give me 59. So 59 will definitely be here. Next to 60, this is where we have 59. Sorry about that. And then it goes with how much? It goes with 180. 180, let's see. Where is 180? 180 is supposed to be below 200. So our 180 will be here. I'm going to say 180 divided by 5. That's 36 times 30, 35. 150, 155, 140, 145, 60, 165, 170, 175, 180. So 180 will be here. Go along with that line, go along with that line. This is 180, right? Sharp. Let me check where is another coordinate. It's 59. It's here. 59, it's going to be here. The point is going to be here. So now let's join these two guys together. So now basically this is how our curve will look like. But now let's have a look at the pinch point. Let's determine the difference between the values that are close to one another. So if you have a look at this point over here, if you have a look at this point over here, what is the difference between this point and this point? What is delta t? And then between maybe, yeah, let's have a look at there, because they look approximately close to one another. It's gonna be 200 subtract what? 150, 155, 160, 165, 170, 175. This will be 175. So that means you're gonna say 200, it's close to 200. So I will take that is close to 200 minus 175. We get 25 degrees Celsius, right? We get 25 degrees Celsius, and we're supposed to get 10 degrees Celsius, but we're not supposed to get less than this, because if we get less than this, clearly there will be no heat transfer, at least if it is equals to that or above that. But our aim is to make sure that we move the blue curve close to, so that we have the difference of 10 degrees Celsius. So here's the plan. This is how I normally do this if I want to be more accurate. So what I'm going to do is I see where this point is at, right? and I see where this point is at. So I will try at least my point will move 10. So I have to shift it backwards a little bit. So let's go change this curve backwards. Okay. Then, so instead of starting at 24 exactly, I'm gonna move a little bit backwards. So I'm gonna start it here. Um, I'm gonna start it here. Let's see. 20, let's start it at 20 degrees Celsius. If we start it over here, right? If we start it here, and then now I want to add 24 units from 20 moving forward. I want to add 24 units, right? So now that means I'm gonna say 20 plus 24, that will give me 44. So next point is gonna be here on 44. Um, so wait, starting from here, at first we started at 24 and then we said 24 plus 24. How much did we get? Oh, we were supposed to move to 40. Oh, that was fine. We started at 24, right? At first, we started at 24 and then we moved how many units? 20 units and it took us to 44. So right now, I am starting at 20, right? As a point of reference, I'm starting here. This is like my zero. This is like my zero. And then I want to move 24 units. So meaning it's going to be at 44 because if I say 20 plus 24, that will give me 44. I hope that makes sense. So, and then the next temperature, it is how much? It's 140. It's going to be 140. 44 is here. 44 is here. Let me check that one. That one. It's here. Yeah, here they meet. Erase this. And then the second point from 44, I'm gonna add how much? I'm gonna add what, 15? I think it's gonna give me the same thing. So 24. So 20 plus, oh yeah, no, I think I see why it makes sense. Plus 15. It will give us 59 again. Okay, no, it's fine. Let's see. Because we changed the point, the starting point. So 59, it will give me, it goes with 180. So there is my 180. Wait, 59, 59. This is 59. Where is my 180? There is my 180. Right. So now let's draw this. Curve like this. Now let's work the temperature difference then. Uh, from here to here, this is huge temperature. Again, this one gives us, it's like 200 minus 170 still. We still have the same problem. That is 200 minus, what is this line? 175. Yeah, it will still give us 25 degrees Celsius. And then we move it back again, okay? You're gonna have to move it back again. I understand why maybe it gave us that number because we started at 24 and we're still at 24. So now we come back here. And let me move it here now. Let's move it a little bit back. Started at 15. Should we start at 15? Oh, let's start it at 10. Let's take it from 10. Let's start it at here. Wait, 20 degrees. Now let's start it here. Right. And then from 10, we add 24 again. So we're going to say 10 plus 24 because 10 is our reference point. It goes to 34. So where do we have 34? Let me erase this, guys. They're not going to be helpful anymore. We move to 34, 30, 31, 32. This is 34. This is 34. 34, it goes with how much? It's gonna go with 140. 140. Where's my 140? My 140 is there. This is 30. I know this side is 34. 140, 140, 140, 140, 140, 140. There it is. Now look at the temperature difference. Let me see. It's gonna be 150 minus 144. 150 minus 144. 140. Not 144, 140. That's 10. Good shot. And then now we move to, from 34, we add how much? We add 15 plus 15. From 34, we add 15. That will give us 49. 49, where are you, buddy? 49, where are you? Here's our 49. Here's our 49. 50, and this will be 49. 49 goes with how much? It goes with 180. 180. 180. 180. Where is 180? See? 180, 49 goes with 180. Right? 180, where are you? This line over here, it's 180. Where's 49 again? Ooh, we have a problem. 49 goes up, 49 goes up, 49. They touch, they touch, they touch, they touch, they touch. We have a problem. All right, that was a good shot over there. From here to here, that was a good shot because you can see it's 10. And the problem is they touch over there. We shifted it too much. A little bit too much. See, that's some sort of a trial and error. Okay, hopefully this time I'm gonna get it. So we moved it too much at the back, right? So now where am I going to move it? Let's move it here. That was at, we skipped 15. Let's move it at 15. Let's move it at 15. 20, 15, let's move it here. This must give us something at least better now. And then what else? Where do we move? Where do we move? Okay, from 15, starting from 15, it's like starting from 15, I'm gonna say 15 plus 24. 15 plus 24, this must give us a better result. It's gonna give us 39. So we go to 39. And we have what? 140. 15 plus 34, 15 plus 34, 24 is 39. Here's my 39. No, it must give us something close at least. And I'm gonna repeat that unless we get something close. 39, 140, 39, 39, 39, it's here. Okay, 140, that's a good shot again. I hope it's not gonna touch there. God, I hope it's not gonna touch there. And then from there, from 39, we add how much? From the 20, from 39, we add 20. That will be 59. I think did we do 59 before? 59 will be here. This is 59. And then 59 goes with how much? 59 goes with from 140, 180. 180, 180, 180, 180, 180. I see you there, buddy, 180. And then 59, it's here, close to, no, oh, here, 59. This looks perfect. 180, 59 is here. Oh my God, this looks so perfect now. We must be happy now. And then, wow. And then what do we do next? Next, we move to, we're gonna add 59 to 15. 59 to 15. That will give us 74. We move to 74 goes with 230. 74 goes with 230. Give me your 74. 77, 74, it's here. Goes like this. Okay, that's fine. I'm just marking to see where am I. It goes with 230. 230, yes, 230. This is 200. 205. 210. 215. 220. 225. 230. 230, it's here. Above this line. Then our last point is here. Awesome. Awesome, awesome, awesome. This is perfect. Now we can join. So this is beyond perfect. This is perfect. Join this. Ooh. Join this to that. Join this to that. Utilities there. Then join this to that. And we know for cold, we are hitting it. It goes up. So if you look at the pinch point over here, we have what? From this point to that point, we have 150 for cold, for hot. And then for cold, we have 140. And then when you look at T minimum, because they are very close to one another, that's T minimum, we're going to say 150 degrees minus 140 degrees. Definitely this then will give us 10 degrees Celsius, which is T minimum. And therefore, this is how we draw the composite curve. Okay, that was too lengthy, but hopefully you understand now how to draw these composite curves over here. And thank you.